You're listening to Let's Talk Creation with Todd Wood and Paul Garner, the creation show where we learn, grow, and worship.
Well, welcome back to another episode of Let's Talk Creation with Todd and Paul. I am Todd Wood.
And I'm Paul Garner.
And this is another fantastic live episode. As you can see, we are off to explore God's actual creation here. Rather than just talking about it. Last year, I took you to the courthouse to learn about the Scopes trial, and we spent some time exploring the Smoky Mountains. So this year, I thought I would take you to a different sort of place to celebrate one of my favorite topics, and that is life itself. So this morning, we are off to the Tennessee Aquarium in downtown Chattanooga, Tennessee.
Oh, it sounds really great. So why don't you kick us off then, Todd, by telling me a bit about the history of the aquarium?
Sure, yeah. So the original building is themed around freshwater creatures, and that opened in 1992. And the whole building is sort of themed around this idea of following water rainfall as it comes into the high Appalachians and then flows down into the Tennessee River. There are other rivers and lakes and that have exhibits in the aquarium as well. And I've lived now, 34 years, I think, in the Appalachians here. And I love this aquarium. I think it's an absolute love letter to the beauty of this region and the living things that call it home. I just think it's spectacular. So the original building now is called River Journey. In 2005, they opened a second building called Ocean Journey, and there is obviously things that you'd find in oceans. The building itself is about half the size of River Journey, but it holds almost twice as much water, about 700,000 gallons versus 400,000 gallons in the original building.
Wow.
Yeah. I don't know how much that is in liters or cubic meters or whatever. I don't know. But I guess if you're not from America and you don't know how much a gallon is, I'm sure you can do your own conversion. Anyway, so before we go in, I thought we should mention here, even as I am singing the praises of the Tennessee Aquarium, we are not affiliated with the Tennessee Aquarium. Nothing that we're saying here represents any opinion of the Tennessee Aquarium itself. This is an absolute disclaimer about any approval or anything like that from the aquarium. They had nothing to do with what we're about to say. This is our own little creationist interpretation of things. So if you don't like it, if you don't like what we say and you're upset with us, then blame me and leave the aquarium alone. Okay. But go see it anyway, because it's great.
Oh, yeah, I'm looking forward to seeing it as well. So, yeah, let's go see it.
Yeah, absolutely.
Well, Todd, I've been over to America on many occasions, and I've been to some really incredible places. I've been to the Smoky Mountains, I've been to Grand Canyon, and so on. But what is so special about this place, the Tennessee Aquarium?
So you might remember earlier this year, we had an episode about viruses, and I was very excited in that episode to talk about life as a gift from God. Now, as a biologist and a biochemist specifically, I know a lot about metabolism and molecular details of of what makes us alive. But at the end of the day, none of us really have a good definition of what life actually is. It's a mystery. And in that mystery there, we find this reflection of the great giver of life, the great creator. And I think of all the things in creation that reflect the glory of God, which we're told in the Bible is what creation is doing, there's something very personal about the living things. Stars and galaxies, mountains and oceans, they show God's power. They show what God can do. And that's very important. No doubt about it. And they're beautiful. But living things kind of show us what it is to be alive. And since God is the source of life, Jesus said, I am the way, the truth, and the life. If you want to understand the full dimension of what that means, I think you kind of need to look at living things, which reflect that core essence of God himself. And there's an amazing amount of creativity in living things. Chemistry and physics they're great. I love chemistry. I've taught chemistry. I've studied chemistry. It's great stuff. But they feel kind of like the tools and the materials that God uses to craft the real crown of creation, and that is living things. So living things are kind of like God's artistry unleashed, right? He sort of lets it all break out, and he's made the little pieces, and now he's going to do something really amazing. So living things are just endlessly surprising. They're breathtaking in their beauty. They're just theologically profound in the way we think about God and the way we think about his creativity. And anybody who really wants to look closely at living things and listen carefully for what the Creator wants us to learn is going to come away really enriched from that experience. And the last thing that excites me about the aquarium is how many of these stories highlight our own work and research in creationist biology. So, Paul, I did a little recon visit to the aquarium to remind myself of everything that's on exhibit and figure out if there were enough good creationist stories we could tell. And there are a whole bunch of them, and I couldn't get them all in. So this episode, we're gonna cover some topics, but there's more to the story. So this is gonna fit into a number of the themes that we talked about on the show the past 90-some episodes. Things like created kinds, diversification of living things after the flood, natural evil, design. All of these themes come up again and again as you walk through the aquarium. So I hope that our audience will not just enjoy seeing this beautiful place, but will enjoy learning about the exhibits through our own creationist perspective. And if you're listening to this, I encourage you to go and check it out on YouTube, because there's a lot of cool visuals that you're going to want to see.
Yeah, that's really exciting, and I echo all of that. It's really great. So I'm looking forward to this. So why don't we begin then with the original building, the river journey, and let's go take a look at that.
All right. So let's start here in the river journey by talking about all the species we have in the area. The southeastern U.S. from Kentucky down to the shores of the Atlantic, and from, say, the Mississippi over to the shores of the Atlantic. That's kind of the southeastern U.S. And then the Appalachians then turns into this massive, what we call a hotspot of biodiversity. I'm sorry to use big words, but that just means there's a surprisingly dense amount of species living in a very small area. And it's true of a lot of different things. It's not just fish, but salamanders and flowers and all sorts of things. And part of the reason for that is the rainfall, which is abundant in this area. It's almost 5 feet every year falls in this area, which is that's a lot. There are some places, in fact, Paul, some particular isolated coves that are actually technically classified as temperate rainforest in our region. They're not very big areas, but we do get a lot of rain. And then you have the landscape, right? The mountains that creates a lot of these little isolated places for creatures to live. And so you've got a lot of different mountains, you got lakes, you got streams, all sorts of different streams. So there's a lot of places where species can find their own little niche and live. And so, yeah, there's just an enormous density of species living southeastern United States, especially the Appalachians.
Yeah. You know, one of the things that strikes me about all of this is a related term, disparity. You mentioned the term diversity. Now, diversity describes the fine level differences between creatures, the differences that you see between species and varieties. But disparity looks at how different these things really are. Let's take, just for example, a salmon and 5 species of frog.
Okay.
Right? How much diversity have you got? Well, you've got 6 species, right? That's the diversity, 6 species. But the disparity is actually only 2, Because really all that you've got is a fish and some frogs, right? That's the disparity. Now, when I look at these displays of local Tennessee fish, I see maybe 40 or so different species of fish, but they belong to only 6 families. We've got the minnow family, we've got the perch family, we've got the sucker family, the salmon family, the killifish family, and the sunfish family. So there's 6 families. So we've got high diversity, 40 or so different species, but the disparity is not that high. You've got 6 different families. So how would we understand this then as creationists? Well, I guess as a creationist, I'd understand this pattern to represent the diversity of species within created kinds. You know, as creatures recolonized the world after the flood, they encountered different habitats, different environments. You use the term different ecological niches, and they became locally differentiated. Now, Charles Darwin, in The Origin of Species, used this kind of evidence to argue that very similar species found on isolated islands probably evolved from a single ancestral species. Now, within the creationist model, would that be the same interpretation, Todd, would you say? Or are we thinking about it a bit differently?
Yeah, I mean, there's sort of, he's on the right track, but I think he got off track. So it's not exactly the same way we would think about these things. So for example, all the different minnow species that we have here in the aquarium, I would understand that probably as related to a common ancestor. Same for the different sort of salmon species, the different killifish species, the different families that you mentioned. I would think those are all probably created kinds. And that would be pretty much in line with how Darwin would think about things. He would have said, yeah, look at all of these similarities. They testify to, at one point, a single species of killifish or sunfish or salmon or whatever that then gave rise to these other species. But where Darwin diverges from my own thinking and from creationist thinking is this issue, as you mentioned, of disparity, right? That there's this, we think that indicates that there's a limit to Darwin's inference of a common ancestor. The way that, how far can this common ancestor really go back? So it seems to me that so different minnow species are often very, very slight variations. And so, yeah, you could imagine those being related to a common ancestor, but how far back does that go? Can we really say that about, different families of fish or different families of other creatures? Can we say that about different classes like mammals and birds? And Darwin would say, yes, you can absolutely do that. There's no limit. You can go right back to the very beginning of life itself. But I don't think that's true. So a number of years ago, I asked my colleague, Roger Sanders, we were thinking about the Darwin bicentennial celebration of Origin of Species that was coming up in 2009. And I asked him to look into this limits of variation, but I asked him to do it on oceanic islands, right? So that was one of the ways that Darwin sort of convinced people that species really descend from common ancestors. He said, look at these isolated islands where you have all these species that are very similar to one another and not similar particularly close to anything on the mainland, right? And so he said that indicates that those species arose in that set of islands from a common ancestor. So I asked Roger, I said, why don't you figure out how much divergence that represents, right? Are we talking about different species of a common genus or different genera of a common family, different families of a common class? How far does this go? And what he found was not far at all. That when you follow Darwin's argument, what you mostly find is that there are these species that show up on islands but they do tend to be fairly similar to things that you would find on the mainland. You rarely found things that were really strikingly different on an island to the point where you would say this is a whole new class of creature. That just doesn't happen. So to me, that suggested, well, we're seeing then is that Darwin's argument really kind of has a natural limit to it. You can get new species, you can occasionally get new genera maybe, but you're not going to get new families or new classes. That's very unusual. Maybe it's even impossible. I would think that might be true. And to put this back into sort of explicitly creationist terms, I think it's possible to generate new diversity, new forms within a created kind, but I don't think we can generate new created kinds. I think only God makes new created kinds. That's kind of what that limit really means.
Okay, Todd, I see here in the aquarium an awful lot of turtles, and I know that creationists have looked at turtles in some detail. So why don't you tell me about that? Because I know you've also looked at this particular question.
Right. Yeah. So let me start with turtles and my friend Wayne Ferrer. Wayne was a professor at the King's College for many years. He was also, for a time, president of the Creation Research Society. He was for a long time a member of their board as well. And he was just the nicest guy. He was so sweet and kind and considerate. A real blessing to me. And his expertise was in turtle classification. He was the first creationist that I know of to really look in depth at turtles. And he sort of had different ideas at different times. One of the suggestions that he put forward was there was at least 4 different created kinds of turtles. And then when I looked at turtles, when I was studying the Galapagos Islands, I kind of became interested in the relationships of turtles to everything else, because turtles are really, really different kinds of creatures. They've got these unique, these shells, right? And the shells are made of expanded ribs, and their hips and shoulders are moved inside the rib cage. And that's pretty much unique as far as we know among all the sort of vertebrate animals. And that's really the biggest difference there. And I suggested that, the unique anatomy of turtles would really set them apart as being something unrelated to anything else. And this is another aspect, another application of this idea of disparity. Sometimes disparity tells you something is so different, it's really hard to imagine how that could possibly have evolved. And the shell there is the thing that makes the turtles unique. Now, since my work on Galapagos, there have been a number of really startling discoveries that are supposed to show the evolution of turtles. One of those is a Triassic turtle called Odontochelys. And Odontochelys is really weird because he has a kind of a patchwork incomplete shell, and he's got teeth. Modern turtles do not have teeth. So this was this was said to be a sort of a primitive, evolutionary, early turtle. And there's also been things called Papochelys from Germany and Eunotosaurus from South Africa that are supposed to represent close relatives of turtles. My study of all of these things have shown that they're really not, they're not like turtles. They're kind of their own unique created kinds. Odontochelys specifically. So yes, I am aware that these things exist, but no, they don't really cross the major gaping discontinuity between turtles and everything else. And now as we go through the aquarium here, we can see 2 types of turtles, living turtles, that I also think happen to represent at least 2 created kinds, probably more, but definitely discontinuities between them. One of them is the hidden neck turtles, and the other is the side neck turtles. So the hidden neck turtles are the ones that we're most familiar with here in the eastern U.S. Their necks curl up vertically, and then they are able to pull their heads all the way back into their shells. Box turtles here in the eastern U.S. is a great example of that, where that turtle has a little hinge on the plastron, which is his lower shell, so he can pull his head all the way back in, close up that hinge, and he is completely encased in his shell. It's very cool. Long neck turtles, these side neck turtles, they retract their heads to the side. They are not able to move them up and down in the same way that the hidden neck turtles do. And so they tend to have very long necks, and they kind of look really strange to us Americans who are familiar with our little hidden neck turtles. And so, yeah, they're very different. So that anatomical difference there is one of those things I think that really clues me into the idea that we're looking at something that's just a completely different created kind, or multiple created kinds.
Okay, well, we've skipped out of order here on our tour around the aquarium because I wanted to draw your attention to another example of discontinuity. We've come to the Ocean Journey building. And obviously, here we are checking out the penguins. This is really fun. You can see them sort of frolicking around and swimming in the water. They're amazing. The kind of torpedo-like way they swim underwater. It's absolutely fantastic. They're so ungainly on land, but then, you see them, they're so elegant under the water. There are two species that we have on exhibit here, and they have fantastic names. There are the Gentoo penguins. The Gentoo penguins are recognizable because they have a white patch behind their eyes. And then we've got the macaroni penguins, which have a yellow tuft on the top of their heads. And what I wanted to point out here was the uniqueness of penguins as a group. Again, Todd, this is something you've written about, I know.
Yes, I have. Yeah, definitely.
There are a number of modern penguin species. They range all the way from the tiny Galapagos penguin to the emperor penguin that's about 4 feet tall, about 1.2 meters tall. And I think it's easy for anyone, anybody who's at all, familiar with them, to just recognize penguins. They immediately stand out, don't they, as different from everything else. They all have this very, well, what can you say, a very penguin-y look.
Right.
But Todd, what is like a penguin? I mean, what other birds are penguins supposed to be related to?
Well, the earliest penguin fossils that we know about are from the Paleocene, which is basically the first big set of rock layers above the last of the dinosaurs. So they're essentially almost as old as the dinosaurs themselves on the conventional timescale, right? But as long as we find them in the fossil record, they've been pretty recognizable as penguins. So the nearest relatives are supposed to be other seabirds, birds like petrels or albatrosses, or maybe loons, things that are other seabirds. Yeah,
Okay.
As I was studying this, it all struck me as very implausible.
Okay. Yeah, I mean, I'm somewhat familiar with those birds. I mean, I'm sure people know what an albatross, looks like.
Yeah.
And it has to be said, none of those birds really look similar to penguins. Penguins are very distinct, and it certainly seems to me that penguins are another one of those discontinuous groups that they must have been created separately from all other birds. They are just so different from even their nearest supposed sort of evolutionary relatives. They are just so distinct, aren't they, as a group?
Yeah, I completely agree. There's nothing like a penguin, just like there's nothing like a turtle. No. They're very distinct. All right, Paul, I'm very excited to show you this tank right here. We're at the Rivers of the World section on level 2 of the River Journey Aquarium building. And this tank here contains fish from Lake Tanganyika. And that is one of the African Great Lakes, and it's home to at least 250 species of fish from the family Cichlidae. So these are cichlid fish. Other African Great Lakes have their own unique and diverse cichlid species as well. So Lake Victoria is another one of the African Great Lakes. It's home to about 500 different species of cichlid fish. And then Lake Malawi, another one, has more than 800, maybe more than 1,000. So there's this massive amount of diversity of cichlid fish.
Yeah, wow. I mean, here in this display, I can see maybe 11 different cichlid species. And to me, they look quite different from one another. In fact, if I didn't know that they were all cichlids, if the kind of signs didn't tell me that, I might come to the conclusion they were very different types of fish.
Yeah, absolutely. So even as we sort of marvel at the number of cichlid species in these African lakes, we also have to recognize that you kind of have to be familiar with what makes a cichlid to recognize a cichlid, because the diversity is enormous. It's just enormous. But when you look at their genes, they're all very, very similar. And so scientists conclude that they all must be very closely related, even though they look so different. They call this an adaptive radiation. Adaptive meaning the species have become very adapted. That's not a very good way to define something. But yeah, adaptive means that they're very fit for a particular part of the environment. Some of them are bottom dwellers. Some of them are sort of near shore fish. Some of them exploit different kinds of food sources and so forth. They call it a radiation because there's a huge number of species that they think were produced evolutionarily in a very short amount of time. And in fact, the African cichlid radiation is one of the most celebrated examples of adaptive radiation. Every time I go to an evolution conference, there's always multiple talks about cichlids because they're utterly fascinating and people are just enamored with them. So our understanding of sort of the recovery of the world after the flood includes numerous new species being generated from survivors in each created kind, right? So there's certain kinds that make it onto the ark, the terrestrial kinds, and there's 2 of every kind there, except for the clean animals. And then the survivors outside the ark, there's more per kind, but maybe not a lot. In any event, there's a lot of them. There's a lot of speciation. There's a lot of generations of new species in a very short amount of time. And every now and then, an evolutionary biologist will notice or discover or stumble upon what we creationists have been talking about, and they criticize us for that. But it's really interesting to me that even in the evolutionary mindset, they're sort of forced to admit, yeah, sometimes speciation happens in a very rapid way. It just happens very rapidly, even within their own evolutionary timescale. So maybe what we think is going on after the flood isn't so outlandish after all, or unusual. And maybe studying adaptive radiations might tell us something about the way created kinds diversified and survived in the world right after the flood.
Yeah, right. And you're right. I mean, cichlids are one of those classic sort of textbook examples of this, but there are also lots of other examples of adaptive radiations as well. I mean, we can think of Darwin's finches, the Hawaiian silver swords, which are a kind of flowering plant found on the Hawaiian Islands. You've got honey creepers, which are another group of small birds. I think they're also members of the finch family. These are other sort of famous examples of adaptive radiation, where you just have this sort of explosive production of new species. So these aren't particularly sort of rare occurrences. They seem to happen quite a lot, and that seems to be, an important feature of the history of life. So even when you try to interpret the evidence from an exclusively evolutionary viewpoint, you still discover that speciation, the production of new species, really can occur explosively at times.
Absolutely. And I think that's terribly important. All right, Paul, we've come now to the Ocean Journey building officially. We've had our little penguin preview, and now we are properly in the building. We've just been through the opening Tropical Cove exhibit at the top of the building, and there are crowds of people having a good time over here petting the stingrays, which we quite enjoyed ourselves. But I brought you over here to a quieter corner that most people ignore because I want to show you these.
Yeah, now I'm no botanist, but I do know that these are pitcher plants. Tell us about these.
Yeah, they are definitely pitcher plants. These are tropical pitcher plants. They're different from what we have here in North America. These are from a genus called Nepenthaceae. Now, they're common in Southeast Asia. And I've been fascinated by carnivorous plants for a long time, partly because they sort of fit nicely into this question of natural evil that we've been talking about in our long-running intermittent series, because it seems to turn creation upside down, right? God, in Genesis 1, he says to the animals and to people, I'm giving you all these green plants for food. And here we have plants that eat animals instead, which is really odd turnabout there. These structures that they use to eat the animals, the bugs, as you can see, they're not simple at all, not even remotely. The pitchers, first of all, they form these remarkable pitchers. They contain digestive enzymes, so there's some biochemical adaptation down there as well. They have inside, they're lined with these little hairs that face downward into the water. So if you're a tiny little bug trying to crawl out, you're going to be constantly kicking against these hairs, and it's going to keep you down in there. The pitchers accumulate liquid that helps to drown bugs that fall in. So they seem to be really well designed to do what they're doing. So what's the deal? I mean, did God give bugs to these pitchers to eat? Is that what's happening? Now, with Nepenthaceae, what's interesting about these particular pitcher plants here, there are two really, I think, fascinating examples of species that literally do not feed on insects, even though they go through the procedure of producing these pitchers. So in the highlands of Borneo, there are 3 Nepenthaceae species where tree shrews use their pitchers as toilets.
Oh, wow.
So those plants get their nutrients not from eating bugs, but from the tree shrew droppings. So it's literally a tiny toilet. And then also in Borneo, there's another example of a Nepenthaceae species where the pitchers are used as roosts for bats. And the bats also leave droppings inside of the pitcher, and that gives them nutrients as well. So 2 examples there, that 4 different species of Nepenthaceae, 3 that are basically tree shrew toilets, and 1 that is a bat toilet. So surprise, who saw that coming? I didn't.
I think that's amazing. And it's just one of those great examples where you've got this natural evil where the plant is killing animals for food. But then when you sort of begin to look a bit more closely at this example, you can actually see that these bug-killing structures aren't always used for killing bugs, right? So, maybe that's giving us some clues about the original design of these plants. Maybe they were designed this way. It was part of the original creation, but they were just being used in a very different way. And we've thought, haven't we, as we've done our series about natural evil, we've thought about things like pit vipers and their incredible apparatus for sort of killing and feeding on prey. And it's kind of hard to think of some other function for those things, but maybe there is. Maybe there is some other different function, and we just haven't discovered that yet. That's a possibility. So it's just a reminder, isn't it, that just because something appears to be designed to harm or to kill, it doesn't mean that it was always intended to do that originally. There are these little glimpses, these little hints that we sometimes have in creation of how things might have once appeared to be very different.
Right. I love. You see why I love these guys? This is amazing. And this is why we should come over here and take time to look at the pitcher plants instead of all the little fish. And I think this is one of those things, I talk about this in my book, The Quest, these signposts, right? Sometimes you get discouraged and you think, are we really on the right track here? But then you find out that pitcher plants can be tree shrew toilets. And so suddenly something that looked impossibly designed, beautifully designed to trap and kill creatures is actually, in weird cases, could have completely different uses altogether. And I think that's just beautiful and remarkable. And it gives me a kind of a hope, right? That we are on the right track, and that, eventually maybe we will sort of figure out what vipers were biting back before the fall.
Well, here we are watching some jellyfish. Very relaxing to watch these things as they're sort of moving around in the water. But in some cases, of course, it can be dangerous to encounter jellyfish. Now, these moon jellyfish are quite common in the UK. They don't have much of a sting. But what about this Pacific sea nettle? It's a very beautiful animal. But is it dangerous to us, Todd?
Yeah, good question. I am told, I have never touched a Pacific sea nettle, so I cannot testify to this myself, but I am told that this animal has quite an irritating sting that burns, but it's not terribly life-threatening. But there are some jellyfish that can be life-threatening to human beings, and literally rubbing up against them can endanger your life, if not just flat out kill you. So even as we're looking around at these beautiful animals, moon jellies aren't terribly annoying. And even the Pacific sea nettle here, which is just stunning. It's unpleasant, but not dangerous. But there are creatures that could very well end your life if you happen to stumble across them.
Yeah, so there are some of these things that can really ruin your day.
Yeah.
And the way they do it is the sting, the sting of the jellyfish is basically caused by a cell called a nematocyst, which has a structure called a nidocyst. It's kind of, the nidocyst is like a coiled up harpoon. You can sort of think of it that way. And there's a trigger on the surface. So when you kind of brush up against one of these things, or when the prey animal or whatever it is, brushes up against this nidocyst, it causes the harpoon part to shoot out and inject toxins into whatever brushed past it. It's really an incredibly well-designed structure. It's much like the fangs and the venom injection system of the pit vipers that we've already talked about.
Right, yeah. So we've seen a number of these creatures today that have these sorts of things. The corals have these stinging cells. And so do the sea anemones, like these guys right here. All of these things have a very simple anatomy. They have like a tentacle, they have like a ring of tentacles that surround this opening to the gut. And it's a kind of a dead end one-way opening. Our guts, it's a one-way street. You can think about that. Goes in one opening, comes out the other opening. That's for the waste. But with these sea anemones and jellyfish and so forth, they're more like cul-de-sacs, dead-end streets where they come in and go out the same way. Creatures, they don't have any brains. They just have this sort of a neural network that sort of moves prey from their tentacles into their mouths. And then they can also coordinate their movement, squirting water out of that gut opening. So they're very simple animals, but at the same time, like you said, they have these incredible nematocysts, and you described them beautifully. It's literally this little physical trigger on the surface of that thing, and you hit that trigger and it'll shoot a harpoon right into you. So even though, you look at them and you think there's not much to it anatomically, it's still a remarkable design.
Yeah. And, we kind of thought about bats and tree shrews and some of the insights they give us into, pitcher plants. Have you got a similar story here with these jellyfish? How could these jellyfish maybe live in the pre-fall world when they weren't stinging and killing prey, presumably? Have you got a similar story here?
Well, sort of. And this is a story that I've sort of pursued as well. So it's becoming more well known now that there's this intriguing lake in a Pacific island country known as Palau. And that lake contains jellyfish that do not sting. So obviously, if you like diving, or if you like swimming, going to a place where you could just swim with jellyfish is a pretty cool thing, right? Because they wouldn't sting you. So it's kind of becoming a tourist destination. So it's intriguing because the jellyfish have inside their bodies, they have these algae that help to produce food for them. And so it's thought maybe the algae are making their sting essentially unnecessary. That algae is feeding the jellyfish, and so the jellyfish is just swimming around with the algae inside. So that's a really intriguing idea. But we do have examples of other sorts of creatures like this that also have algae, and they still sting. So a long time ago, I got some, they're called hydras. They're a common sort of high school biology project that you look at under the microscope. And there are green hydras that have algae in them. And I thought, I wonder if they have stingers that are reduced compared to the regular hydras that don't have green algae. And the answer is not really. We would feed them little water fleas, and the algae containing hydras would eat just as many water fleas as the non-algae containing hydras. So it's not a full explanation, but it is, I think, very intriguing that you can have jellyfish that don't have stingers at all, or that don't sting anyway, and they have these algae in them. So it's quite interesting.
Yeah. So although it's not a kind of simple story that, if you've got algae, therefore it means you don't sting, it's not quite that simple. But nevertheless, I mean, it still gives us some intriguing clues into maybe ways in which the original creation might have been quite different. Just because some things in the modern world look as if they're designed to do one thing, to harm or to kill, it doesn't mean they couldn't have been doing something different maybe in the world before the fall. So that's really interesting.
Yeah, I think you're exactly right. That every time I look into the sort of the living world of the oceans and the streams and the waters of the world, I always find these really intriguing kinds of examples where they're kind of giving us, the lesson is that you people lack imagination. You can't imagine how these perfectly designed creatures that are perfectly designed to kill could possibly not do that. And then, you look at these jellyfish without stingers, or you look at these pitcher plants that act as toilets, and they're like, nah, there's ways of doing it. So don't give up hope, I guess, is the big message.
Yeah, absolutely. Well, we've come to the end of our tour through the Tennessee Aquarium. It was all too short. I've really enjoyed seeing it. And after seeing all of those amazing fish, Todd, we've come out for fish and chips.
Yes. So the aquarium is not only good at showing us the beauty of life, but it also is good at making us hungry. So we definitely had to come out for some fish here.
Yeah. We had to come out and have fish and chips. I mean, just seemed the natural thing to do. Now, as we kind of went through the Tennessee Aquarium, I mean, one of the things that just strikes me about it is that it's just such a fantastic display of the creator's incredible beauty and design, all of these incredible things that we saw. But it was also a great way to explore some themes in creationist biology, which we've already kind of dug into to some extent, in previous episodes of the podcast. So we had the opportunity to think about created kinds, the whole concept of disparity and diversity. We thought about adaptive radiations, how the created kinds might have diversified in explosive ways. We thought about the importance of discontinuity, how we have these very distinctive groups. And we thought, for example, about turtles and penguins, and how different they are from their closest evolutionary relatives, if you like. And we also thought about natural evil. We thought about some incredible sort of examples of natural evil and some of the insights into the world before the fall. So it's been a great day. I wish we had more time to explore because, as you said at the beginning of this episode, there are so many other stories represented here in the exhibits in the aquarium that we just didn't have time to look at today. So maybe we can do that some other time in the future.
Yeah, maybe we should put another aquarium episode on our vast list of ideas for future episodes.
Yeah, that would be great, because there's so much more to say, I think.
But as usual, I think everybody knows we have a giant long list, and we're always coming up with new ideas for new themes and new episodes, and we're always always interested, and welcome your ideas as well. So if you have an episode idea, be sure to pass that along, and we'll think about how we might integrate that into our plans. As always, we've greatly enjoyed sharing our time with you, our listeners and audience. I really hope you've learned something, and I really hope you've had a good time just worshiping God, the Creator, as we've just looked at some of his amazing and beautiful creations here at the Tennessee Aquarium. So we will see you in 2 weeks for our next episode. Bon appetit, Paul.
Bon appetit, Todd, and we'll see you in 2 weeks.
Well, as you can see, we are not at the aquarium. We're back in our respective studios, recording.
In inverted commas.
Yeah. And we just wanted to pipe in here at the end of the aquarium episode to remind you that it is the season of, unfortunately, fundraising. Here in the United States, most nonprofit organizations and Christian ministries are bringing in 30 to 40% of their annual income in the few weeks there between Thanksgiving and New Year's Eve. And Core Academy of Science, the co-sponsor of the podcast here, is no different. We are seeking this year $50,000, which is a whopping amount of money. Makes me nervous thinking about it, but I know the Lord knows our need, and the Lord will provide everything. He has promised that in his word. And but we do want you to be aware of the need. And so we thought we'd pipe in here at the end of the aquarium episode to remind you of that. As you also know, we spend a lot of time and effort putting this podcast together, especially this episode. People have been begging me for years to put more graphics into the show, and I keep telling them that's going to take forever. Post-production on this episode was multiple weeks of full-time work. This is why we don't do a lot more extra graphics. But if you've enjoyed this episode, I think it's beautiful. I think I'm really, really pleased with it. If you've enjoyed this episode, please do consider making a contribution. Paul, how can people make a contribution to Let's Talk Creation?
Well, they can go to our website, letstalkcreation.org, and there are options for giving there. And that would be fantastic to send a donation at this time because, as you say, like many ministries, we have, and I'm talking collectively there about Core Academy of Science and, Biblical Creation Trust that co-sponsor the podcast. We've taken a bit of a hit because the economy's not performing great and people feel the pinch, and we understand that. Yeah. But if you are able to help us out at this time, that would be fantastic because it will help us keep this content coming. So let's talkcreation.org. You can also, of course, go to our respective websites. So if you're in the UK or you're in Europe and you want to give to Biblical Creation Trust, you can go to our website. That's biblicalcreationtrust.org. And there's a giving page. You can just click on the link and it will give you all of the options. And Todd, if there are people in the States who want to give to Core Academy, they can do it through, obviously, our podcast website, but they can also go direct to Core Academy, right?
That's right. coresci.org/donate is the address. We'll make sure that's in the show notes. We'll make sure all of these addresses are in the show notes.
Yeah.
So you can find ways to support us. And you mentioned, Paul, wow, the pinch in the economy. Yeah, it's crazy. I pop into the grocery store to get a few things and it ends up being $90. And I think, how did that happen? How is this stuff that much? It's crazy. So yeah, we definitely feel that. But we also know that, everything that we do, 80% of our income is because people just want to give us money. And so we are very grateful for that. And we definitely need that continued support. The podcast itself costs about $17,000 a year to produce between the time that we take researching and arranging for recordings, the time we spend on actual recording, and then the time we spend in post-production. It's a lot of effort, and it's very expensive, and we could not do it without you. So we very, very grateful for your support and for all that you do to help us continue this. We hope you find this an interesting, refreshing take on the creation evolution debate and discussion, and we hope that you think that what we're doing is worthwhile. So
yeah, and we've got some exciting plans. We've got some really exciting things coming up, and so we want to keep that content coming. So do help us out if you can. That would be really appreciated. Thank you very much.
Yep. And in 2 weeks, we'll be back again for our 100th episode. Can you believe it, Paul? 100 episodes.
I know. Where's the time gone?
Yep.
We'll see you then.
All right. See you then.
Thanks for listening to this episode of Let's Talk Creation. For more information, visit us at letstalkcreation.org, where you'll find an archive of past episodes and all our show notes. If you'd like to leave a comment or make a suggestion, you can find us on all the major social media platforms. Let's Talk Creation is brought to you in the U.S. by Core Academy of Science and in the U.K. by Biblical Creation Trust. As a listener-supported ministry, we are grateful for all of your financial support. Find out how you can make a contribution at our website, letstalkcreation.org. Also remember to like, subscribe, and share this episode with your friends. Thanks, and see you next time.